Okay, so we know that the mass of the water is 3.40 times 10 to the second grams.
Okay.
We know that the initial temperature of the water is 0.0 degrees Celsius.
Mm-hmm.
And we know that the temperature final is going to be 37 degrees Celsius.
Okay. So what's our delta T?
The change in temperature would be negative 37 degrees.
Okay, so positive 37 because the water is gaining energy, it's heating up. And do we know C of water?
That would be, we're trying to find calories, right? So that would
Oh,
be,
good thinking.
is that 1.000 calories over grams degrees Celsius?
Yes. So just like we have joule per gram degree Celsius for water, it's also 1 calorie per gram degree Celsius. And he's giving us four significant figures for that, I think he did. All right, so we'll plug into our equation. So how did you go about it? Because you can solve things or...
I didn't do the practice problem, so I'm just doing it right now.
Okay, talk me through it.
We're going to start with the general equation, Q equals M times C times change in temperature.
And please write your equations. Even if you completely miss the problem, I can give you some partial credit if you just do that. This right here, awesome. Okay, then you keep moving forward, plus this helps you to set up the problem. All right, next step.
Then we're going to plug in the mass.
I keep wanting to write 4.184. No, I want joules so much. All right, and delta T is a positive 37.0 degrees Celsius. So our grams cancel, our Celsius cancels. And then if you type it all in, what do you get?
We can use 3 significant figures, I believe. No,
You've got
1.
3 here, 4 here, and 3 here.
Yeah, 3.
So 3.
Would that be 12.6 degrees Celsius?
What's our unit? If we cancel grams and we
I'm
cancel
sorry, calories,
Celsius,
yeah.
calories. Okay, so Q is 12.6 calories. Worth it? Good way to lose weight?
Okay.
That's just chemistry calories. Convert them to food calories and get how much you're really burning.
So what would that be?
That would be, you would divide that by 1,000, and then you get 0.012 to 126 calories.
Okay, so,
That's not a lot.
right.
Take a lot of time to burn.
Right. So we do not think that
Yeah,
that's
I've heard
going
that.
to, actually, what do we get here?
You
340 times 37. Actually, this would be 12.6 kilocalories. Because 300 times 1 times 37 gives you 12,600. So it really would actually be 12.6 food calories. So 12 calories, you could drink a giant cold glass of water and eat an M&M and even it out. So, you know, if it's worth it. Okay, so we'll move on to number 9. Solve. Oh, you get the hard one. So this one takes some setting up. We are ignoring the calorimeter though. So I'll set up over here in case anyone needs that. But here's our problem. The calorimeter is filled with 150 grams of water at 24.1 degrees Celsius. So very similar to what we did today, right? A 50-gram sample of metal is heated to 100 degrees Celsius and dropped in the calorimeter, and it causes the temperature to increase 5.4 degrees Celsius. What is the specific heat of the metal? This is exactly what we did in the lab today. So, when I do these, just like on those extra calorimetry problem sheets, I always make a chart. If we're ignoring the calorimeter, we only need 2 pieces to the chart. The metal or substance, if it's not a metal, but it is this time, and the water. And then I just write everything I could possibly know. So I could know Q, I could know M, C, temperature initial, temperature final, delta T, for all of those things. So, and then you just look at the chart when you're done filling it in and you say, what do I know the most about? I'm going to start with that. So, go straight through the problem, Saul, and tell me, what do I know?
We know the mass and the temperature of the water.
Okay, what's the mass of the water
150 grams
and the temperature?
is 24.1
That's
degrees
initial
Celsius.
temperature. Okay, what else do I know?
The mass of the metal is 50 grams.
Okay, mass of the metal, 50.0.
Yes,
Okay. Anything else?
and it's 100.0 degrees Celsius. No.
Okay, so initial temperature for the metal is 100.0 degrees Celsius. So, does it give me a final temperature?
It gives us the difference in temperature.
Oh, it gives us delta T, so what's that?
It's 5.4 degrees Celsius.
So the water goes up 5.4 degrees Celsius. Okay, so can I find the final temperature of the water with that?
Yes.
Okay.
It'd
so-
be 29.5.
All right. Now, I still don't know enough about any one thing to go anywhere with that. So what can I plug into the chart that I do know that I haven't filled in yet?
We can find the heat of the water.
Okay, so how do I do that?
We multiply the mass times specific heat times change in temperature. We know the specific heat is 4.184 joules per gram Celsius.
Good. So that's the key point right there. If you get to the test, you get this chart done, you really want to set up a chart like this, I promise. You're like, oh, there's not enough information. You probably know something that you're just not thinking about. There's often the specific heat of the water, maybe somewhere at the top of the test. This happens, I don't know if it happens on this test, but he gives you like tidbits of information at the very top of the test. It'll say like test 2, the gravity on the moon is 4.2 meters per second squared. And so then you'll need that in a problem, but you'll be like, oh, I don't know what the gravity of the moon is, but it might be at the top of the test right under the title. So if you get stuck, look there. You need to memorize the specific heat of water, though. He does not give that to you. What's our goal?
To find the heat of the water so that
That's our first goal, heat of the water, but our overall goal is specific heat. I should have done that. Okay, so go ahead and help me plug in.
so
And I know it's tedious to write all of it out, but what do you get?
I have
Can I tell you in there? Are you able to see it?
3,400 joules.
Okay, and you kept 2 because that, so that works for me. So water gains 3,400 joules. So now, what else do you know? Where, is that what I actually got? Yes, awesome. Okay. This is a totally different problem, so I'm gonna erase it. All right, so now I know everything to know about water. What can that help me with metal?
In order to know the heat of the metal, we need to, the heat of the metal equals the heat of the water plus the heat of the calorimeter.
Okay, and we're ignoring the calorimeter.
So it would be 0.
So QH2O plus 0 for the calorimeter equals what? Close?
It would be the same thing.
Except
It's negative.
negative. Okay, because all the heat the metal loses, the water gains. So the negative just shows the metal losing heat, the positive shows the water gaining heat. So we can fill in. Negative 3,400 joules. Every bit of heat the metal lost, the water gained. I can't say that enough times. All right, I still don't know enough stuff to find C. This is where you hit the wall and you're like, okay, I have to know something that I haven't realized I know. What do I know?
Would the change in temperature be the same as water?
No, because the metal didn't only gain or lose 5 degrees. What is always true at the end of the calorimetry experiment? Think of when you did it. You took the temperature at the end, and what was the temperature of your metal at the end of your experiment today? Was it the same as the water?
Yes.
Ah, that is always true. That's the goal here. Key point. Goal is everything. I mean, the experiment's not over until everything is at same T final. So temperature final is always the same for every single thing in a calorimetry problem. So if you know T initial, T final, what can you find?
The change in temperature is 70.5.
Okay, so 70.5 degrees Celsius. And now we're in business. We can definitely find the C of the metal now. So Q. Now if I rearrange for C. So the key points to solving this problem, you have to know that you know the specific heat of water, and you have to know that you know that everything ends up the same final temperature. The other kind of key thing that you might need to know if you weren't ignoring the calorimeter is that water and calorimeter are always same temp. So if you're not ignoring the calorimeter and he just gives you temperature points for water, the calorimeter is always, always, always the same temperature as the water. So everything comes to the same final temperature, but the water and the calorimeter always have all three things in common. So if you know those things, you can find all the points for your chart. So help me fill in, Saul. Or just solve while I fill in. Oh, wait, I think we did delta T wrong. Because did the metal increase in temperature?
It decreased.
So T final, 29, minus T initial, 100, is going to give you a negative delta T. If you end up with a negative specific heat, that's impossible. That never happens. Things don't require negative energy to increase in temperature. So then you think, did I not make this negative? Did I get delta T wrong somewhere? That's a good place to check for making careless mistakes, which we just did. All right, so now we can do it. What do we do?
That would be 0.97.
Anyone else get anything different?
Oh, what did you got?
I got 0.96. So one thing I'll say is 2 significant figures is good because there's 2 here, 3 here, and 3 here, so you have to keep 2. So if you've got 2 and you're only off by 100th, that's probably going to be okay. But if I type in 3,400 divided by 50 divided by 70.5, I get 0.9645. But the 0.964 isn't enough to make the 6 round up. So you can't round the 4 up and then round the next place up. So 0.964 has to stay 0.96. And always keep units. Units are important to us. I think we have a couple more minutes. That was 9?
Yes.
9. 9 is 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96. 0.96 Okay, so 10 just doesn't ignore the calorimeter, so you have to do the whole thing. That one is already on YouTube. So, are there any questions?
Okay, I'm not very good at math, so I try to do the calorimetry by myself, and I was so confused, so I listened to the videos. But if, like, after this, like, before the test, I'm gonna study again, do you have, like, a tip for that, like, to rewatch the videos? Or do the work with you during the video, or?
Well, how about you do number 10 with us now? You've probably seen it once, but let's do it. We've got time, and that is probably a good use of our time. So everyone put everything away, so you can't see what you did before. And we'll see if we can get through 10, which is probably the hardest problem in the module by ourselves. And Brittany, you can write. You won't see any math any harder than this.
Should I keep filming?
You don't need to film this because I have it open all the time, so
Alright.
we don't have to overload you too.
Bye.
It's okay.